So we're going to start talking about shields, and we'll talk about an Ethernet shield just to start with. In addition to talking about shields in this part of the class, we're also talking about networking, right? Internet of Things, right? So we're finally getting to that internet part of Internet of Things. How do we connect to the internet? So an Ethernet shield is generally giving you a wired connection to the internet, which may or may not be what you want, but right now we'll start with that. So it allows internet connection through a wired interface. And so you can look at it and you can see the picture there. This is a typical Ethernet shield. The shield includes an Ethernet jack, a port, an RJ45 port. That's the plug. You can see the big plug there where you plug an Ethernet cable into. So a network cable you can plug into that RJ45 port. There are several shields available. So this is one Ethernet shield, but there are a lot of different Ethernet shields available. But they use a common library. They all use the Ethernet library that's provided by Arduino. So a few things we got to get straight before we can really talk about the Ethernet shield, because there are some setup activities you have to do. So we just got to go over what internet addresses are, because some of these parameters have to be set up when you start using the shield. So, or they don't have to be, but they can be set up. So we need to review what these are. And we've covered them a little bit in the beginning, but we'll cover it again real quick. A MAC address. So a MAC address is a unique address which is hardwired into each network adapter. It's 6 bytes long. It's a 6-byte long number. Now I put hardwired in quotes because theoretically it's supposed to be hardwired, but in reality with these Ethernet shields you can change that, right? But if you were to buy a component off the shelf, buy any component, heck, say a laptop. Let's take a laptop. Say I buy a laptop and it's got Wi-Fi and wireless, right? Wi-Fi and wired. It's got an Ethernet jack and it's got a Wi-Fi adapter. It would have 2 MAC addresses. The Ethernet would have 1 MAC address, the Wi-Fi would have another MAC address, and those would be fixed in there and you can't change those. But with our Ethernet adapters, our Ethernet shields, most of the time we can actually change the MAC address. Or sometimes they come with a MAC address on them and on a sticker, but we can usually change them. But they are unique. So it is assumed by Internet protocols that the MAC addresses are different. So no 2 devices should have the same MAC address. So when you're making up a MAC address, this isn't really realistically a problem for us, because when we're doing this, we're going to be doing this in our local network. So maybe we'll be talking just amongst the machines in the room or something like that. So as long as there isn't any interference in MAC address between the machines in the room, which is highly unlikely, we won't have a problem. But generally, if you're talking on the big wide internet, every MAC address has to be different from every other MAC address. And companies do this by, every company that makes Ethernet adapters and network adapters, they get their own prefix, MAC address prefix. So every one that comes from a particular company has the same first several bytes. And then the rest are determined by the company, and they ensure that they're different, they're distinct. But the different companies have different sets of most significant bytes, so they can never interfere with each other. So there's a MAC address. And we're going to have to set the MAC address on our Ethernet shield. There's also an IP address. Now, an IP address is 4 bytes long, and it's used in internet addressing. So when you want to send to a machine, you send to an IP address. Now, the IP address can change, however, unlike the MAC address. MAC address is not meant to change. It's supposed to be stuck with a hardware device for its life. The IP address can change. Now, actually, we can see an IPv4 address. We're only going to talk about IPv4. IPv4 is the earlier version of IP addresses, which is mostly currently still in use. It's basically 4 bytes long. Each byte, remember, is 8 bits, right? It represents number 0 to 255. So you can see this representation up here, this dotted decimal notation, which is very common to see IP addresses in. There are 4 numbers separated by dots. Each number is a number from 0 to 255. So that's what a typical IP address looks like. Now, there's also a port. TCP protocol defines a set of ports. So say you got a particular IP address, like my laptop, okay? And it has its IP address. Right now it is running and it has some IP address. In addition to its IP address, it has several ports that it can use for communication. So the port number generally is mapped to a particular application. So right now, my laptop is over there and it's got a web browser running on it, right? That web browser communicates on port 80, because that is the standard. If you have a web browser, web server, they communicate on port 80. Okay, that's just the standard. So it's listening to port 80. The web browser, when it wants to send a message to a web server, it sends it on port 80. Communicates with port 80 on the server machine, and the server is listening to port 80. Now, if something comes in on another port number, the server will not hear it, will not pay attention to it. It's listening to its one port. So when you want to send something through the internet to a machine, you got to specify the IP address, but you've also got to specify the port number to indicate basically which application protocol you're using. And that's 2 bytes long, which means it's 16K, so there's 16K possible ports. And a lot of these are pre-known. So for instance, it is known port 80 is for internet, for HTTP communication. Now, DNS, or Domain Name Service. What this is, it's a service that maps a domain name to an IP address. So domain name is basically an English, or not English, but a mnemonic name that humans can understand and memorize. And this maps to an IP address, which you need to actually address a machine. Now, so for instance, www.uci.edu, that I can remember pretty easily. That is the domain name, but the actual IP address that maps to is 128.195.188.232. So that translation has to happen every time. So if I'm in my browser, let's say I type in www.uci.edu, it has to get translated into that IP address before I can address that server and the server that's running on that machine. So that's what DNS is for, Domain Name Service is for. Basically, it's a lookup process where you type in uci.edu and your machine, local machine, goes to another machine, a domain name server, a different machine, and asks it, hey, do you know the mapping? Do you know, for this name, do you know what its IP address is? If it knows, it sends it back. If it doesn't, it forwards it to another domain name server, and so on. So that's DNS, Domain Name Service. And because of this, it is common that you have a domain name server, like a default domain name server that you go to when you need to resolve a name. So it's often the case that you configure one of these Ethernet controllers, or in our case, an Ethernet shield, you configure it with a DNS server, with the address, the IP address of the DNS server. So when it's looking up a name, it says, oh, I'm going to go to whatever is in my default list. Now, if you don't have a default list, your network provider has a default also, but you can specify your own if you want to. Thank you.